Right, so we have to go for the question number 9 now. So we will discuss question number 9. So now this is again an industrial question. So we have to focus on the industries that are present in our syllabus. But at the same time, you have to remember these additional information are also very, very useful. Okay, so we will go through it. Right, so this is related to few industrial processes. So manufacturing of bleaching powder, calcium carbonate, urea, and sulfuric acid. So through the contact process. So we have already discussed all these processes, if you can remember. First question is state the starting materials used in each process. So we come from will come from bottom. So sulfuric acid, you know, there should be a sulfur containing ore, or sulfur containing ore. So you can write down sulfur or sulfur containing ore is necessary. And what else you need? And starting material, sulfur containing ore, and there should be some air to provide the reactions to happen really well. And finally, there should be some water at the end of the reaction, right? And urea, you just need carbon dioxide and ammonia. These are typical. And calcium carbide. So calcium carbide means CaC2. So automatically there should be some calcium source and carbon source. So you can use coke here, carbon, coke, to get some amount of reaction with calcium compound. So where is a calcium compound? It can be calcium oxide, or even you can use calcium carbonate to get limestone to get calcium oxide, right? And then the first one is bleaching powder. So bleaching powder means, you know, it's a very, very long reaction. The formula is a little bit longer. You can write down the formula a little bit longer. So for bleaching powder, you need basically calcium carbonate is again needed, because you have to get calcium oxide, which is typically known as quicklime, and you need some then you add water to get calcium hydroxide, which is typically called slaked lime. And additionally, you need chlorine gas as well. This is the final step of the reaction, right? So all these starting materials are needed. Write the balanced chemical equation. So to prevent some time consuming, I have given these reactions directly on the board for few. First one is for the bleaching powder. So initially you will have calcium carbonate, and you heat at high temperature, then you get calcium oxide and carbon dioxide, and then with water it will form the slaked lime from the quicklime. And then finally there is the reaction between chlorine, and we have already discussed this formula. So calcium OCl2, calcium hydroxide, calcium chloride, and 2 water molecules. Okay, so these are the reactions for bleaching powder, and you don't need much higher temperatures. You can go with room temperature. Only here you need higher temperature. Okay. And calcium carbonate. So you have calcium carbonate, you can decompose into calcium oxide and carbon dioxide. And when you have calcium oxide, you can directly react it with coke under higher temperature. See here, the temperature is around 3000 or 3100 or 2900. Plus or minus 100 degrees, you can form this one. So you can write down either this or this. But when you write these two, it is very good. And then urea, you know, carbon dioxide and ammonia react at 180 to 200 degrees Celsius at 150 atm pressure to first form the solid ammonium carbamate. And then at low pressure, it decomposes into urea and water, and you can evaporate the mixture to get solid urea. Okay, so these are the three main processes. And the other one is sulfur. So sulfuric acid, you know that when you have sulfur, O with sulfur with oxygen, it will form SO2, and then SO2 under vanadium pentoxide catalyst with reaction with air between oxygen to form SO3 gas. So this is gas, so maybe this can be solid, SO2 gas. And then SO3, we add a little bit of H2SO4, right? Because when you have SO3, when you add directly water, it will form H2SO4 and H2SO3. So there is a mixture. So to avoid that, what we do is we just add SO3 to H2SO4. So there will be some additional reaction like I will write here. So SO3 plus H2SO4 will form H2S2O7. So we have already discussed this. H2S2O7 is oleum, and then you add little amount of water to that, so it will hydrolyze into 2, giving 2 sulfuric acid, right? So oleum plus water will give 2 sulfuric acid. So these are the reaction that is necessarily participating in this discussion. Okay. So you can write all these reactions, right? These are very simple at this point. And don't forget to mention the temperature and the atmospheric pressure condition when the conversion is from SO2 to SO3, okay, under the vanadium pentoxide catalyst. You can write down that as 450 degrees Celsius at 180. Okay. State two uses for each of the following. So you know what are the uses general, right? Bleaching powder means it can be used for bleaching agents. So this is typically known. This is for bleaching agent. This is one, right? And the other one is this can be used for water sterilization. These are the two common things, right? We use this in swimming pools sometimes in hand calcium. So calcium, this is water sterilization, okay? And calcium carbonate, carbide. So sometimes you have heard people tell, oh, this fruit is not good, this is added with carbide. Naturally, it is always added. So this is used for fruit ripening, right? So fruit ripening. So we use this for fruit ripening, as well as we use this calcium carbide, if you remember, to form the oxyacetylene flame. Okay, because you can use calcium carbonate and you can form acetylene, then use that for oxyacetylene flame. Okay, this is another one. And urea, you use it as a fertilizer rich in nitrogen, or you can use this as for urea or formaldehyde polymer, so fertilizer or polymer. And sulfuric acid to make superphosphates, basically. So phosphate fertilizers can be formed using sulfuric acid, and also sulfuric acid can be also used for making some explosives as well. Okay, so phosphate fertilizers and explosives. So this summarizes our discussion of this question number 9A. Okay, so you see this question number 8 was not hard, informative part A and critical part B. Remembering the reaction with nitrate with aluminium. And even if you don't know the reaction nitrate with aluminium, you should know it is giving ammonia, and the stoichiometry between this ammonia and nitrate in this particular reaction is 1:1, at least that thing. Okay. And then this first part is again very general, and we will move on to part 2. The major environmental problems we are facing at present are ozone layer depletion, global warming, acid rain. The questions given below are related to them. Okay, so we will see, and the problems. Carbon and nitrogen cycles are two important cycles that operate in the environment. With regard to the carbon cycle, state one main form of carbon that is present in each of the following. So we have to find one main form of carbon. Now, actually, before going on to this particular question, I have to mention, so normally these nitrogen and carbon cycles are generally studied by the biology students, right? So more often these questions are not asked in the chemistry paper because there is some unfairness to the physical stream students. Okay. However, this question was asked in this particular year, but these are very basic things. Okay, if you know your chemistry well. So one form of carbon in the atmosphere. So you know what is the main form of carbon in the atmosphere? It is CO2, right? So carbon dioxide is always present in the atmosphere, right? And then plants, you have carbon containing glucose, right? This can be that. So water, what do you have in water? You have carbonate, bicarbonate in water, and in the earth crust, you will have the limestones, calcium carbonate, and maybe dolomite, calcium carbonate, magnesium carbonate. So all those things can be present, right? State briefly how nitrogen gas in the atmosphere is removed and replenished in the nitrogen cycle. So this is specifically related to that nitrogen cycle, right? So you have to mention how this nitrogen is removed from the atmosphere. So primarily, nitrogen is removed via three processes, if you can remember, right? So which removing mean it is like the fixation process, because amount of nitrogen is removed from the atmosphere, right? So we say nitrogen is fixed. So nitrogen can be mainly fixed by lightning. So if you remember about the acid rain scenario, so nitrogen can be formed in NO2, then HNO3 and acid rain. So basically it can be removed from lightning, and then nitrogen is fixed via the Haber process, so industrial fixation. Okay, so Haber process. And finally, don't forget nitrogen also can be fixed by microorganisms present in the soil. So this factor might not be known by the physical stream students. Okay. So these two, and the last one can be nitrogen fixation by the microorganisms, especially by the bacteria. These are rhizobium bacteria. Okay. So this is also done. State two ways by which microorganisms participate in the carbon cycle. You see here, they give microorganisms just to, you can think here in the second one, oh, maybe nitrogen also can be fixed by the microorganism like bacteria. So here in the third one, they are again relating this to the carbon cycle, and they by which microorganism participate in the carbon cycle. So what is actually happening here in the carbon cycle? So we gave an example for the carbon, these plants, this starch and all those things after the death, they have some carbon amounts. So basically these microorganisms undergo respiration. So aerobic or anaerobic respiration with these carbonated compounds, right? So carbon compounds. So state two ways means, what are the two ways? So the two main ways is under aerobic conditions, these carbon compounds can be converted to CO2. That is the main one. This is under aerobic condition, right? For an example, if you remember about your glucose reaction, so C6, H12O6. So basically under aerobic condition with oxygen, so it will give CO2 and water. So these carbon compounds under aerobic condition is converted to CO2 by these microorganisms. That is one way. The other way is in the absence of oxygen, these carbon compounds can be, now this is oxygen present, and this pathway is oxygen absent. So oxygen absent in this condition, this is mainly converted to methane or carbon monoxide at some cases. So these are the two main ways, right? Under aerobic or anaerobic condition. Aerobic condition to CO2, anaerobic condition to CH4 and CO, right? Moving on. So this is about the cycle, little bit of cycle. Identify the two main nitrogen containing compound present in the atmosphere that contribute to acid rain. So we have already discussed this many times. So this should be NO and NO2. With aid of balanced chemical equation, show how this compound make rainwater. So we have discussed this many times, right? So NO with oxygen will give NO2, and this formed NO2 and this NO2 already present in the atmosphere will react with water and oxygen to form HNO3, and finally HNO3 can be decomposed to give dissociated in the aqueous media to give H plus and NO3 minus. So these reactions are very straightforward. Okay. And the third one is identify two contributing industrial processes per environmental problem stated above. So we have to find some two contributing industrial processes for each of these problems and identify one chemical compound that is liberated to the atmosphere by these industrial processes, right? So what you have to understand here means these industrial processes, but this ozone layer depression, global warming, or the other one is acid rain. Then what can be one of the chemical compound that can be liberated from this particular process? Okay, so ozone layer depletion. So you know that in the air conditioners you are using, so industries that make these air conditioners, they mainly use this CFC and even HCFC to form these chemicals which depletes the ozone layer. Okay, so this is one. And then when you go for global warming and in agriculture, you use CH4 methane and nitrous N2O, right? So N2O, don't forget N2O, which can be affect to the global warming, as well as in coal industry, some coal industries, CO2 is emitted, which also affects our global warming. And finally, acid rain. So this can be fossil fuel combustion giving NO and NO2, which is the example of this second question, or even maybe some coal power plants that will give sulfur compounds like SO2, which also can be from H2SO4, giving acid rain. Okay, so this is one of the another questions, detailed one. And fourth one is finally identify the main industrial process that contributes significantly to the addition of nitrogen compounds to water and soil. Comment on the pathways by which these compounds are added to water and soil. So first thing is to identify the main industrial process that add nitrogen to water and soil. So what is the main process that is where nitrogen is fixed? It is Haber process, right? Because that is the main one, industrial process. Because other two we normally discuss is lightning and the fixation by microorganism, which is related to question number 2 here in the first one, right? So main industrial process is the Haber process, and comment on the pathways. So how this is added to water, right? So don't forget that ammonia can be converted to fertilizers, because when you have Haber process, we fix nitrogen to form ammonia, and this ammonia can be used to form the fertilizers, right? So when you have these fertilizers, so what is happening actually? These fertilizers can be manipulated by using some acids like HNO3. So we use HNO3 to convert this ammonia formed from Haber process to form some other fertilizers. So this mainly can cause and this some adverse effect and get added these compounds to water bodies. right? Because when you have these fertilizers, you mix it with these nitrogenated HNO3, like nitric acid. So these can be then added to aquatic systems like water bodies, right? If not, into the soil, so you directly add the fertilizers into the soil, and what is going to happen? Because of the microorganisms like the nitrification bacteria, nitrosomonas, and nitrobacter can directly add these compounds to soil. You see, you have to know a little bit about the carbon cycle and nitrogen cycle in order to completely answer this question, right? Right, last one. Inappropriate disposal of solid municipal waste in a methotamola even contributes significantly to one of the three environmental issues stated above, right? So identify this environmental issue and state briefly how the disposal of solid municipal waste contributes to it, right? So think about this. What is actually happening here? So you have municipal waste, right? So waste, it might contain a lot of organic compounds, carbon compounds, right? So these carbon compounds, and in these waste, there can be many microorganisms that can undergo aerobic and anaerobic respiration, right? So they decompose all these materials, giving CO2 and methane. So CO2. So that is what we discuss here in question number 1, part 3. See here, aerobic respiration giving CO2, and here anaerobic giving methane. So these two are mainly contributing for global warming, right? So what is the main environmental issue? So it is global warming. So how? Have to mention this little bit here in the same way. This will form and it will contribute significantly. Okay. Right, so this is a brief explanation of this part B, and so we have to move on to question number 10, and we will finish up here. Okay.